We've just finished, or the last section covered a discrete random variable. Now I'd like to cover what's called a continuous random variable, a random variable that can take any range of outcomes. But we're going to focus our discussion on a specific type of continuous random variable, and this is what's called the normally distributed or normal random variable. This normal random variable we're going to first kind of simulate as a discrete value, but we can see that it is actually a continuous value. So the characteristics of a continuous random variable. The vertical coordinate is a function of the probability density function. What does that mean? That means that it's the probability that the outcome will be that number or within a range of numbers. The range of possible values is along the horizontal axis. A normal distribution can take any value between negative infinity to positive infinity. So if we wanted to know what is the probability of an event occurring somewhere between A and B, because this is a continuous function, we would actually integrate between the values A and B. So the total area under the curve is equal to 1 or 100%. There's a 100% probability that the value will take the place, the outcome will be somewhere between negative infinity and positive infinity. As an interactive demonstration, I'd like to go to this website and show you what a normal distribution looks like. In this example, we can decide how many times or how many times we want to sample. I'm going to increase the bin sizes here. Decrease the bin sizes. If we show that we only do 100 samples, so we're grabbing 100 observations from some distribution, we can see that the outcomes are discrete. That it falls within these bin ranges. There's a small probability of this event occurring and a small probability of this event occurring. Most of our events occurred within this area, but we can see the normal or bell curve start to develop. As we increase the number of trials, we can see that that bell curve develops even more, but because of randomness, we can see that there's still these anomalies, these areas where it didn't meet or match expectations. But as we learned in previous sections, as you increase the number of trials, the outcome approaches our expectation. So we can see this normal distribution. Normal distributions occur quite frequently in nature, and they have nice mathematical characteristics. Now, the probability density function is quite complicated as the equation that you can see here. And we're not going to focus on that. We're going to use three methods to come to probabilities and then assess from probabilities an actual value. We can see that a normal distribution has these characteristics such that the mean is right in the middle for a symmetric distribution. If we go one standard deviation to the right and one standard deviation to the left, we can find that we get another 34% of the probable outcomes described. If we go two standard deviations to the right and two standard deviations to the left, 13.5% plus 34% times 2, because it's both sides of the distribution, gives us about 95% of our possible outcomes. So that's the nice characteristic about a normal distribution, is that we can define the probability of an outcome occurring simply by knowing two numbers. First, the mean, or the center, and second, the standard deviation, or the deviation from that mean.